All right, how's it going, guys? So this week we're gonna actually be done with the mean app. So the last couple times, as you guys know, we went over the mean app. I did actually update the GitHub page to include the logo that was an appropriate size. What I found was the issue is it had to have the same ratio. So if you went to the styles, I might as well do it. So if you go to here, problem solving, bang, bang, bang. And then if you go to styles, the ratio basically had to be the height 1 to 2 basically is what I ended up using. So what I actually used was 400 pixels by 800 pixels to keep it nice and crisp when it got sized down. So yeah, here, this is it. And then if you were to, I don't know if I could do properties from here, no, but it's 400 by 800, 400 for the height, 800 for the width. Yeah, so that was all you had to do. I upload that, that's to Git. So the next thing we're going to be working on is machine learning, which is a very new and happening field. This, along with artificial intelligence, AI, I don't think we'll actually get to. This is also the last week before finals kick in, so I probably won't be back at it for a couple of weeks. But I really do plan on connecting our mean app with, say, the context GUI that we built with Qt or with Python, the TK interlibrary. I really want to connect that with our backend by accessing the URL and getting the data that way. And the other thing I really want to do is show you guys how to integrate the Google Assistant, build a Google Assistant app, which is super useful, and how to use your REST API to handle the Google Assistant app. So those are the two things that we haven't done. Another thing I might want to do is how to upload images and whatnot, which really isn't that hard. They're all actually pretty easy because everyone wants you to use those applications. They make it really easy, and the documentation's great. Integrating the Google Assistant took a little bit for me to kind of work around, so I think that tutorial might be the most useful since it's not playing out in the site. The images one is actually pretty useful. It took me a while to figure out. Nobody has, I think, in my opinion, the correct way of doing that. So I kind of integrated a couple of things to make it the cleanest and the most accepted by separating files a certain way to keep it clean. Otherwise, people, I think, make it very messy and they just don't care about it. I care about keeping the code clean, so I think I do it the best way. Personally, not to toot my own horn. And then the other one was integrating it with the backend. Now those, just look up curl for C++ or the response library, I think, for Python. And getting is very easy. It's you have to actually, the problem would be when you post, since we use the login, you have to save the token within your program and then log in every couple of minutes by sending something to the login URL and retrieving the token. So yeah, so anyway, without further ado, this is how you install the Python library. The Tensorflow library for Python, so use pip3 install -- upgrade Tensorflow. The one thing I will note is it doesn't work with ARM chips. It works with Intel, and for as long as, it works with Intel. It should work with AMDs, I want to say. I could Google that right now, but I won't. But I would assume so, since they are a booming company, especially with their new Ryzen chips. But yeah, they would work with Intel, but it doesn't work with ARM, so it won't work on Raspberry Pis. It won't work on a lot of single board things that are built these days. Like NVIDIA had the Jetson board, that it doesn't work on that either. At least the newest Jetson, people do find workarounds, like on Git. People, you might be able to find a library. I don't know. I just don't like that. So it works with Intel currently. There's light versions. The newest thing actually is TensorFlow JS, which is pretty amazing. So currently, as you guys saw, I have the TensorFlow hooked up with my website on my local website because it won't run on the Raspberry Pi, but it's going to actually become a lot easier to do that. Once I look into the TensorFlow.js library, I'll probably do a couple of tutorials there. Another thing I would like to do is show you guys how to run a Python script through your Node.js application. which is pretty good. But that won't be today as well. But anyway, getting really carried away. It's super exciting, this whole field and how to integrate it with everything. And once it is integrated, there's just so much you can do. So yeah, now you guys are really, once you guys get to this, and then artificial intelligence, and then you guys are just, the world's at your fingertips. Like, you can do so many fun things. You can do so many fun things with everything we already learned, but this is just the newest and greatest, and it's new and great because it's just a lot of fun. So anyway, yeah, so once you install that through your, so yeah, you just have to run that. I already have it installed, so I won't run that, but then you would have to, like we always do, we have to go to our documents, and then CPP, and then live, and then I put this one in class 8. I already have something in there, so it's already a file, so, oh, maybe not. Boom. Oh yeah, LS is part 8. Alright, so then, yeah, I already have 3 files in there. We'll get to those in a little bit, but first, yeah, we'll want to open up Atom and then open this folder. Open this folder up, so as you can see, I have this folder open up. We'll get to those in a little bit on what they are. It'll be for the more fun part of this, but the first thing we'll start off with, I hate it, but everyone does it. It's like the hello world of deep learning and machine learning, and I hate it because it tells you so little about how things work. It tells you enough. I guess Hello World tells you so little as well, but it just wasn't, like, I could see the potential when I made my first Hello World application in C++ that I'll put it to a console. It was beautiful, but when I do this, instead of like seeing all the potential it has, I see like all the flaws that aren't actually flaws. You can actually work around it, but it's harder. It doesn't grab at me as much as the Hello World for other applications do. But yeah, this is like the Hello World. So I'm going to call this mnist .py. There we go. We got. And then the first thing we're going to do, obviously, we're back to Python. So we have to do the import. We have to import TensorFlow, and a lot of people like to do as-tf. I also like to do as-tf. No, that's not what I meant. Good try, Adam. Good try. No. There you go. All right. So then, yeah. So that is. Maybe I'll make it a little bigger for you guys. Try to look up at the board here. Okay. Yeah. So that is how you import TensorFlow. Just like when you use NumPy. We only use it for a little bit, but you use NumPy and you import NumPy as NP. Just, you don't want to type out TensorFlow. You just want to type out TF. So then, and then this is going to go TensorFlow. And see, this is why I think it's the worst. But, it does knock it too much, I think. I think everybody's going to be a little happy with this, so. Tutorials.mnist. So this is basically just, so basically from here, we want to import input data. And basically what that's going to do is it's going to get a lot of data, and that's going to be mnist data. So, okay, so maybe I should go back. But actually I'm going to write this line before I do that because it's equally as relatable to what I'm about to say. So .read data sets, and this is literally copied word. This is the tutorial that is in TensorFlow, like the very first beginner tutorial. Yeah, so that's what this is. So you could go and look at that as well, other places on TensorFlow. And that's actually right where we're going to go, because I really want to show you guys why this is. So maybe we'll go to develop, then probably in for beginners. No, that's a different one. Tutorials probably. There we go, mnist. So mnist, for people who don't know, this is what it is. It's like, it's basically turning handwritten numbers / letters into numbers and letters. So you go but we're only going to be working from 0 to 9 with the integers. So Yeah, so the things that we know about it are it's, what is it, 28 by 28, I'm pretty sure. It probably says it somewhere here. No. Okay, it's going into a lot of things I don't want. This is actually a more advanced tutorial. You can look up, here, let's do that. Actually, I included it in the YouTube, but I'm not going to do that. Tensorflow. Let's try that. I googled that. No. Yes. This is it. The beautiful. The ugly. Here it is. So yeah, so there it is. And what are they? It has to tell me somewhere. They are 28 by 28. Okay, then maybe I said that. I don't know what I really said. But yeah, so they kind of look like this. If there's something there, it gives you 1. If there's something not there, it'll give you 0. Oh, okay, well actually it gives you 0. It gives you ranges, but this 1 hot is turning everything either to a 1 or a 0. So if there's something there, it's a 1. If there's nothing there, it's a 0. To kind of complicate things a little less, to make it even more simple for everyone. But yeah, they're 28 by 28, which is important. So yeah, if you go to here, which is attached in the video, you could read more about it. If I don't do the greatest job, it could be because of my bias, but we'll continue. Actually, before we do this, we're gonna actually comment these out, and I want to show you guys something. So first and very foremost with TensorFlow, this might even be the hello world of the TensorFlow now. It wasn't, but it might be. So we're going to do x equals, and then to declare a variable, the variable. Okay. I'm pretty sure. Variable 9. And then we're going to create another variable, tf dot variable, and we'll call this 10. And then we'll call it w, and then to multiply things in TensorFlow, it's tf.mapmul xy. And then similar to how we open and close CSV files, not that, session as sys, that's pretty standard. Dot run, and then we're going to do and then first we have to actually so then, okay, this is what I want to do with you guys first. Alright, so then we're going to print out w. Print w. And there's going to be a couple of things that yeah, I'm just going to leave it like that. There's going to be a couple of things you guys are going to see here. So run python mnist.py. Oh shoot. Shapes must be rank 2, but rank is 0. So whatever. Well, maybe we'll go like this. So 3, 2, 2, 1. Oh, okay, I could have done a couple of things there, but whatever, we'll continue. This probably will work now. Let's try it. Okay, it doesn't. Rank 1, okay. Well, anywho, let's just do this. So, yeah, mapmul will only work if it's a tensor, and it's tensors that are 2 or more, rank 2 or higher, so what we'll do, we'll set that equal to x times y, and then we'll just print that out. If that doesn't work, you know what I'm doing. Okay, so this is the output, and that's true, it's the output. I'm pretty sure it's not an error. What's happening is TensorFlow, to keep everything, the way it works, to keep everything kind of as fast as possible, is everything's not really declared until you run the session. So this is like, okay, I have a TensorFlow variable to 9, but just keep it as a TensorFlow object, as whatever the TensorFlow variable object in this case, and the value is going to be 9, but that's all we know. It doesn't evaluate to 9, it evaluates to a TensorFlow object of 9. But when you look at it, you wouldn't be able to tell that it's, when you multiply them together, you wouldn't be able to tell that it's 9. Even if I did an X and I saved that. Yeah, it's a variable, but you wouldn't really know what's going on. So then if I do this, and then we actually have to initialize all these variables to get that started before we run the session. So we're going to initialize all the variables, tf dot global variables initializer. So TensorFlow function initializer. You know, if it works, it works. If it doesn't, it doesn't. And then we want to run that. So okay. So then we'll try this. Oh, yeah. So printed that. Here we go. So let's see. I'm not sure if this will work. Hold on. Actually, I haven't tested this out. I thought it would be pretty rudimentary, but yeah. Yeah, okay, so it has to actually session.run. Hold on, this might not work. If it doesn't, we got another thing to do. Okay. Well, no doubt that didn't work. Alright, don't worry though, guys. Don't worry. The rest of the tutorial is kind of planned out. So, 9. Okay, yeah. So, you have to run the initializer, and then you have to run. So you have to initialize all the variables, and then you have to run. You have to run the variable with the session as well, or else you're going to get something else. And then if we run W, let's see what that outputs. 81. Is that correct? 9 and 9. Now I was 10 a while ago, but you know, something happened. Maybe it wasn't ever 10. I don't know. I'm losing it. Okay, so that kind of gives you a gist of what's going on in TensorFlow. It's a little weird, but you have to run the session in order for these variables to be what they are. Otherwise, they're just there as kind of like, okay, we're going to go over another thing called placeholders, which makes more sense to me on why they aren't really initialized yet until you run until you session run the initializer. But we'll get we'll go back to that. Placeholders really are just they tell you that there's going to be an integer that we're going to receive at some point, and we'll go over that. And I think we'll go over that within a couple of seconds. Yes, we will. All right, so we're going to get rid of this nonsense. Not nonsense, actually. It's just not important anymore. I think that should be the real hello world of TensorFlow, but it actually gives you no insight into machine learning, just on how TensorFlow works. But for me, it would be more satisfying than this mumbo jumbo, but we're going to get to it. So first, we're going to set up a placeholder, like I just said. So tf dot placeholder, and then there's going to be a tf dot. We want it to be a float 32. So that signifies that it's nothing yet, but it's going to be a float 32, and the shape of it's going to be set 9 by 784. So this is saying that we really want just a straight, basically just a straight array that's going to be 784 long. So what we're doing is 28 by 28 should be that doesn't, yeah, it does. 8 times 8 is 64, so it should be a 4 at the end. So yeah, that should be 28 times 28. So we're basically collapsing this whole thing. I lost it. Good, of course I did. Anyway, the whole 28 by 28 where there was a bunch of zeros and ones, we're condensing that. We're basically just saying, so the first 28 and then the next 28, we're actually going to put after the first 28. It's just going to be this long line of strings. And it will give us a worse prediction because of that. When we start to predict what the numbers are, it's going to give us a worse prediction. But it actually works out pretty well. So that's why it's the first, and it's the easiest to program with because all you have is 784. And then we're going to take a weight. So the weights are where the magic happens, and that's going to be a tf.variable. And then first it's going to be TF0. So we're going to fill it with zeros of, you guessed it, 784 by 10. All right. And I have another one there for some reason. Oh yeah, because zeros is actually, that's the function. Okay. Yeah, and so yeah, so it's filling as zeros. So then when you multiply them together, it's going to be this, and then multiplied by something of that. So it's going to multiply out pretty well, except it's of 10. So yeah. So anywho. So then we're going to have a tf variable again. And this is going to be a bias. So bias is included. So weights and biases are where everything's all the magic. Like I said, it's going to be happening there. This is what the neural network is going to be changing in order to try to obtain the best prediction. And so yeah, the magic is going to happen here. And biases are used for like normal biases in math. Like you want to set it off 0, or you want to move it. They're for adding to the weights to kind of get them a little closer. So bias, and then this is also going to be of tf.zeros, and it's going to be of 10. Just 10. That's it. Sorry, buddy. No mess. All right, so then we're going to have a y, which is going to be our prediction, our neural network's prediction, which is going to be a tf.nn.softmax. So this is going to basically say, all right, we're going to look at, so then we're going to have tf.matmul, and we're going to multiply the x and the y together, like I said. I mean, x and the w together, like it's a capital W. And then we're going to add that bias at the end. All right, so softmax is basically going to take the prediction, whatever we get here, plus here, and it's going to softmax it to either, in this case, it's going to be 0 to 9. Oh, we have 10 here, so 0 to 10. So it's going to, because we're going to have basically some prediction of 0.0, like 0.1, and then we're going to, all right, so I'll write it out. So this is what it's going to look like at the very end. In here is going to look like something like 0.2, 0.6, 0.5, 0.8. You could print this out as well, just like I showed you. You could print out the, you could print out W as well, but you could print out this part of it to see what's going on. Maybe we'll do that. And then 0.4, 1, 2, 3, 4, 5, 0.3, 0.4. They're actually all going to be really close to 0 except for 1, because this is so well thought through. And then this one, I don't know if that's 10, but then this one's the highest, so it's going to softmax it, and then this will be high, and the rest are going to be zeros. So that's what the softmax does, and that's going to be our prediction. Yep. And since we start at 0, we go 0 to 9. It's like basically if it's the 0 element of the array, it's 0. If it's 1, it's 1. It's 2, 2, all the way to 9. But how do we know it's right? Well, we know it's right because we're going to put in a correct prediction every time. We're going to supply it with that, so placeholder. And then this one's going to be a tf.float 32. And we're actually going to pass in none and 10. And that's going to be our correct prediction. So it's because we have, yeah, it's going to be another one of those long guys. But it's going to be the true one. It's going to be 0, 0, 0, 0, 0, 1, and 0, 0, because it's the correct predictions. Because there's going to be, we're never going to pass in like a decimals or anything like that. So, but it is a float type. So I guess we could if we wanted. Entropy is going to this is going to evaluate our loss for us. Yep. So we're going to do tf.reduce mean. It's going to be tf.reduce sum, and this is just TensorFlow functions that are going to reduce our loss for us. So we're going to have our correct prediction. And this is just functions that'll do that it's kind of just trial and error which one's the best one for you. Log y and reduction indices. Reduction indices which equal 1. All right, and then yep. So that's for our cross entropy, and then we're gonna have a training step, and then we're gonna initialize our variables. So we're all coming together here, guys. Okay. So then we're gonna say train step equals tf.train. No duh, we're gonna train it, and then gradient descent. So basically, we're gonna want to get this as low as possible. So it's gonna follow kind of a slope. So if it starts to go up, it's gonna go the opposite way. If it starts to go down, it's gonna follow that. And then the steps 0.5 dot minimize cross entropy. And then we're going to want to minimize whatever the function that we're returning here. So that's how we're doing that. So we're following the gradient, and we want that to be as we're going to want to find the local minimum. For those who know anything about linear algebra in calculus, interact. Yeah, both of those classes are very useful if you guys want to take. If you guys want to excel in this, I would say you can get by kind of without it, and you can learn it on your own. It's just they help. So then we're going to call that global initializer. Yep. And then we're going to run it just like that. So that way it's run, and they're all initialized, and then we can kind of act on them whatever way we want. So then for. And like I said, I don't know if I said that, I'm pretty sure that this underscore just means that we're never going to use it. So it just basically means we're going to make a loop that goes 1,000 times. So we don't need an index, we don't care about an index, just loop around this batch x's, batch y's, and these are just variables, don't worry, they're not like the other ones where they mean something important. These do not, mnist.train. So then we're just really getting, so then next back. So this line here is just getting a batch of 100 of those 0s and 1s and 9s and whatever. It's getting a batch of those and inputting them, and they all have a label, and that's how we're going to be just kind of seeing if they're correct or not. So, yep, so then that's how we're inputting it, and then we're going to session, and then we're going to run. And then we're going to throw in our train step, feed dictionary, and then we're going to feed it x. So this was a placeholder. So this is how you feed into a placeholder. Batch x's and underscore, and this is going to be batch y's. Is going to be our correct prediction. Batch wise. So this is our label, kind of. It is, but alright, so we run that, and then we come out of here, and after it runs, correct prediction, okay, equals tf dot equal. So we kind of want to know what tf dot argmax 0, 1 and tf dot argmax. So alright, so then accuracy tf dot reduce mean, and this isn't correct prediction tf dot float 32. That's what it is. Yeah, we're gonna print. So now we're gonna session.run those to kind of figure out how we did. So this is accuracy, feed dict equals x, and then we're, okay, so this is what's happening. mnist.test images, and we're gonna feed it a y, and we're gonna call mnist test labels test dot labels. Okay, yeah, that seems good. So then if we run this, let's see what happens. You probably get an error at some point. Also, before we get the error, this right here just wants me, it knows I have a better processor than what TensorFlow is predetermined as. Cross entropy, reduction, keyword argument, reduction indices. Okay, cross entropy. And this is going to be reduction. Indices. Yep, that should be good. We'll try to run it again. Okay, so like I was saying, well, I'll just wait. I'll wait until, okay. Gradient descent. Optimizer. Oh, I feel like I left out a I or something. Yep. Gradient descent optimizer. We'll check that out. Check it out. All right, we'll just keep doing this. But as you can see, it adds an MNIST data. So okay, so this is actually our accuracy is 0.92. So this ran correctly. So that's how accurate we are. And if you read TensorFlow, it's going to tell you that's crap. We've done a lot better since then, but it's really good just to show you kind of that neural networks can learn. We fed it some sort of data, and it is doing pretty well. Now, a couple things I hate about this. Well, before I get to that, this here, you guys might get this as well. Something Jenkins, your CPU instruction TensorFlow binary is not built with AVX2. What that means is that my CPU is better than the CPU that this is, that TensorFlow is just normally built for. So there's build options that I could take to optimize it for this CPU to make it kind of run even faster. Yeah, it's difficult on a Windows, I've found. So you can try to do that. You can look up how to install it with AVX and AVX2. I just found it to be difficult. Maybe it's gotten better since last I looked, but that's just what it is. There's also a GPU version of TensorFlow, which is insanely good. I just don't have a good enough GPU. Your GPU has to be, I think, a GTX 1060 or better, and within the last 2 or 3 years, built within the last 2 or 3 years. I think mine's a 1050. So it just misses out. And then all those, that's the reason is because they come with CUDA. So if your graphics card has CUDA on it, that's what it will end up using. Yeah, so, and then it just can run super fast with the GPU. And if you have multiple CPUs, clearly it can run faster as well. And then there's ways to do that and whatnot. There's tutorials out there. I can't do it, so I won't do it. I won't show you guys. Maybe if I ever buy a better computer, like a desktop, that maybe I'll run as a server or something, and I install like a Titan or something, then maybe I'll do that. But I don't have that, so this is what we got. Still, this is very fast. This is actually a lot faster than a lot of neural networks. The next one we're going to run, how are we doing on time? Okay, pretty good. The next one we're going to run is going to take a really long time for you if you're running it just like this. Maybe with the GPU, it will take less time. I think it might run maybe 2 hours. It might take 2 hours for your computer to get done with it. I think that's the last time I checked. That was what happened with mine, how long it took. I think I just threw on Lord of the Rings and then let it go for a little bit, came back, and it was done. And it works, so that's what it is. So that's the thing. Okay, we'll get to that later. But you can load your latest saved version of it, and then that's it. So you train it for 2 hours, and then you have this copy. If it works, you can just implement it many places, and it takes maybe like it's not real time, but to evaluate something, but it's close to it. So you can just plug that somewhere, and then it could just, you feed it information, and it just spits it back out to you. So yeah, it takes 2 hours to train, but then to use, it takes a lot less. So something I would like to do, okay, before I get to that, let's get to what I don't like about it. So first off, what just happened? That was my first impression when I did this. I was like, what the heck just happened? Yeah, sure, I can understand these words are very pretty self-explanatory. We have a placeholder, we have variables. These are of this format of a matrix of some sort, and yeah, so that's what's going on here. I can understand that these are the types that they are. This is multiplying, this is filling it with zeros. I can understand that. We're reducing it, that's great. Based on this function, the reduce sum of that, of whatever that is. The correct prediction of the log of the real prediction. Yeah, I get it. That's great. Reduction in C1. Who knows? I don't know. Gradient descent optimizer. Great. I know what a gradient is. Clearly, we want it to descend. We want to optimize that. We'll take short walks, and then we'll minimize the cross entropy, whatever we get from this function that we just described. Then we initialize everything. Good, great. We go, we get data. Good, great. We run it. We plug it in. That's awesome. Predictions. We evaluate to see if the correct prediction was made. Then we test our accuracy on that correct prediction. We run that with the test images. That's another thing with TensorFlow. As I'm going off on this tangent, this is actually important. My point of my tangent is I think is important. Okay, so there has to be a difference between the train and the test. There's also something that's validate, that's kind of an in-betweener. But the main thing, if you're trying to do something, you don't want to train it on the same thing that you're testing with, because what's going on with TensorFlow is it's optimizing the crap out of it in order to whatever data you give it for it to best match that. So it could give you 100%. So say I gave it a lot of zeros and it just matched the crap out of it. Then I gave it like perfect zeros, and then I gave it a squiggly zero. But I never tested that. I just gave it back one of those perfect zeros, that like a perfect circle zero that it already had, and it said, I got it 100%, I know what's going on. And then I gave it something that I never saw before, and it's like, nah, it's not a zero. And you're like, but it is. That's hopefully a good analogy off of what we just did. There's a lot of other really good examples of that, but we haven't done much with neural networks, so it's hard to kind of describe those. So yeah, if you give it perfect zeros, and then you give it a squiggly zero, but you never ask it if it can get the squiggly zero right, then you're not going to know how well it's doing. So what's going on here is it's testing. It's giving it images it has never seen before. Like if we put back the test things that we got from here, this batch, this train next batch, if we put one of those in there, it probably would give us a 100%. It would be, you got it, 100%, we got this. But that's because it's seen it before. When you give it something, you have to give it things it hasn't seen to measure its accuracy. And what's going on, it's never training this part. We're never training, when we throw in the tests, we're not retraining the neural network. We're just testing it because we want to keep those test ones to keep testing it later. We don't want to train on those because then we lose we can't test with those ever again. I hope that made sense. You could look up the difference between train and test as well. It's pretty simple. I'm just trying to make sure I get it across to every single person that could watch this. So, yeah. So that's that. But my biggest problem? Okay, we're feeding it data, but what the heck is this data? We got it from here. Yeah, sure. We downloaded it from here, but we have never seen it. We saw an example of it on their site, but we never saw what form it's in, what the heck is going on. So I actually never even looked, so I'm going to look up here. Okay, so I actually did look at this. It's in a zipped folder, so you can't even look into there. But the TensorFlow can apparently unzip it and whatnot, but that's the data. Like, this is it right here. I don't know. I don't know. So I looked at that and I just kind of was like, okay, this is great and all, but how do you do your own? And that actually kind of took me a while. Even the next tutorial that I'm about to show you, it still doesn't use its own data. It kind of gives you something. It gives you something in a great format and something that you can read other than a zipped file, which I was kind of ticked off. I think they should do it a different way. Never mind. Yeah, so, but then this next tutorial gives it to you in a good data format, but still it's difficult, it's not great, and TensorFlow says not to use that format. It says it can read that format, but the best way to do it is not in that format, so I had issues with that as well. For me, it just was the biggest thing with all of this, like you're like, yeah, it's great, I get it, you're minimizing as best you can, I can understand it, but the biggest thing I always thought was how to feed it its data, how to see the data. It's kind of difficult. It was kind of difficult. Hopefully this clears it up for you, this next part of the tutorial. What I'd really like to do, maybe I can do it. So what I'm actually going to, so we train it. Okay, so I'm right here. Feed ms.test images. I feel like there's a lot of them in there. I'm only going to feed it one. So we're just going to print y. Print y, so the wrong prediction. Well, maybe the wrong prediction. And I'm just going to feed it one of these. So I'm assuming this is an array. I've never tested this out before. So we'll try it. I don't know. I don't know what will happen. Cross your fingers. Everyone. I don't know. Could give us an error. It did give us an error. Cannot feed shape 784 to. All right. Let's just try to give it. Maybe it's only giving it one. Let's try again. I don't know. There's a way to do this. I did it a long time ago to kind of see what's going on in there. Okay. So this is y. 1, 2, 3, and then it gives you all this. So actually this prediction was this one because 10 to the negative 1. Let's print. Can we print y 0 maybe? It's also giving us without this. Okay. Oh well. Let's try that. I only want the 0 one. Let's see what it gives me. Okay, cool. So it did give me one. So as you can see, maybe you'd think that this one. Oh, no. Which one is the right? Okay, yeah. Maybe you'd think this one is it because it has a 4-point, but it's giving it to you in scientific notation. So technically, this one was a. This would be 9, 7. Oh, 9, 8, 7. So this one would be 7. So that's kind of what you're seeing. This is what the prediction is right now. So it's going to be, it's very close to a, it's not perfect match, but it's really close to it. This one is not close at all because it's 4 decimal places. The next closest one would be a 1, 2, 3, 4. How 4s and 7s look alike? I don't know. But that would be the next closest one. It's still not close. It's two orders of magnitude off of how close this one is. Almost 3 because it's a 1 instead of a 9. So it's about as big as a difference as you can get. Well, 0 and 9, but whatever. But then it would even, once this did 0, it goes back to another 1, so then that would miss our point. So it's about, but yeah, so this would be the next closest one technically. It's still not close. Almost 3 orders of magnitude off. So that's what you're getting. You're getting, this is what the prediction was. It was a 7. Hopefully that made sense. It gives you the probability in scientific notation. So it's almost a 1%. So yeah, and that's how that goes. So now let's get out of this. Let's get out of MNIST. Not the biggest MNIST fan. So what we're going to do is we're going to look up how to make data. So what should we name the file? Sentiment, because that's what we're going to be doing. Sentiment, and then we're going to call it data. And let's see which one I'm going to do now. All right, cool. This one. All right, so I'm just going to throw a lot of functions at you guys. Sentiment data.py. Where did it go? Oh god, no I didn't. Yes I did. Boop. Alright, it's back. It's back, we're happy. Alright, so first off, what we're going to want to do is import Tensorflow STF. Adam, you gotta give me a break, my man. Space, enter. Import numpy as MP. And then we're gonna want, so we're gonna do a couple of silly things here, but hopefully you guys understand why we're doing them. So we're gonna import CSV, import datetime, and then from random import rand. Alright, cool beans. Alright, we're moving on. So the first thing I'm going to do is I'm going to create a record. And this record is just going to be a class that will take in a label and some data. So a record. I name it record because then this way I can use it somewhere else and I know it's just whatever data we're trying to save, or whatever data I'm dealing with at that point. And label, and then data is going to be how you initialize it. And then we're going to return a self label, and that's going to be equal to the label we pass in. And then we're going to have a self data, and that's going to be equal to the data we pass in. I'm going to turn out this autocomplete here pretty soon. Alright, and then we're going to do get label, def get label. Label, then we're going to obviously pass self. And then we honestly we don't even need, you could probably just call record.label, but I always like to do this just because I think it's appropriate. I think it's proper code. So some people would say it isn't, but to each their own. Except for when I yell at them for it, like TensorFlow. Just went off on a tangent, and so to not each their own on that one. Yeah, so then we're gonna basically, if you guys have your CSV reader close by, but I'm just gonna rewrite what's gonna happen. So basically, we're gonna have a CSV file. And we're gonna try to make sense. We're gonna try to import that into our TensorFlow. It doesn't like CSVs, just so you know. It's actually very difficult to work with them. It took me. And it doesn't have to be CSVs. This is just an option showing CSVs. We've gone over CSVs. We can also use our Mongo database. We can go with the response library, which I haven't showed you yet, and get all the, say we stored, I haven't even told you guys what we're working on. So basically what we're working on is I attached it in the, we're working on this. So basically I attached this underneath the video. It's great. It's really well done. If you copy it word for word, your code is going to look sloppy. It's not meant, I don't think it wasn't meant for you to kind of keep that as like a good looking code. It's kind of just to show you how a lot of these things work. I'm going to get into a lot of what these words are, but basically what we're doing is we're going to take a sentence, and or sentences that's lower than a certain number. We're going to take sentences, and then we're going to evaluate them to see if they're positive or negative sentiment. So if they're like, and this is done with using data from IMDb movie reviews. So if it was a good review, that's because you can evaluate to anything. Like I had a bad day, it'd be like, okay, that's bad. But we're using the movie reviews because they have explicit language, not explicit as in bad. Like it's well defined. Like they said this is bad, and then you know that that's a bad review. They mark that as like a 0, or they mark it as a 5, and then those are taken as positive reviews or negative reviews, and we use those as positive and negative sentiments. I hope that makes sense. Yeah, so that's what we're doing. And then we're going to be able to put in text like, I'm pretty sure I showed it in the very beginning, but I just in my blog, if I described my day and then I hit check sentiment, it would check the sentiment, and if I had a good day and I was describing it well, it would say it was a good day. It would say positive sentiment. And if I had a bad day and I was describing it accurately, it would say bad day. It's a senior year though, so no bad days. Bad days for the GPA probably, but no bad days for me. Bad day when I get the test back, but short-lived. Keep fighting, my people. We'll get there eventually. Alright, so basically what I'm doing right now is just reading in a CSV. We've done this before. I'm going to have something that's called data. But then what I have to do is I have to replace all these. So I'm going to store them as a NumPy array, which is silly. This is silly. I'm going to, don't do this. Well, do this to kind of figure out to kind of get through this whole tutorial. I highly recommend to do this. But when you actually start to work with something, don't. Just, that's all I have to say. Just don't. What I would do is not save it as a NumPy array, but save it as some, like the actual string of text that I'm telling you, like I had a good day. Like save that text, and then read it in, and then convert it to a NumPy array, and then send it to what we're about to send it. What TensorFlow likes, as I'm typing all this, because I'm taking forever to talk and type, what TensorFlow likes is, geez Louise, Zach, figure your stuff out. Really, I put a capital out? All right, sure I did. What TensorFlow really likes is TF records. Clearly, that's the one they like because they call it TF. And then I'm going to probably do string input again, let me guess. So this is just whenever I import, it's saving the NumPy array as a string, so when I import the new string, I'm going to have to take away since it's array, it literally has these, and I just have to take those out. And then once you take them out, you just convert to an array, and then you're good to go. And a NumPy array again. So you're saving it as a NumPy array, then you're reading it as a NumPy array, but it's really to show you guys how to, no, not that. String input dot replace. So yeah, I'm oh gosh, I gotta finish this thought. Replace. Yep. So yeah, even though we're storing it as a NumPy array, we're really showing you how to read it in something from a CSV and store that into the correct format, which is a TF record. And then TF records make it really easy. It's not only fast. It's not only the fastest. But it's also the quickest for you to program up. Once you have it in a TF record, there's nothing really. It's good to go. You're good to read it. Reading it's very easy. Reading a TF record. And then also converting is really easy. You don't have to do it every time. Like you don't have to run your neural network, and every time you run your neural network, you convert to a TF record. Just sometimes, like after you get so much data, so say I blogged like 30 times a day, so maybe every week I save that to a TF record, and then one day I just run the neural network using the TF record I saved. Maybe I've been saving it for 5 weeks, and then I just, so then I run that neural network. And then I have 5 weeks stored of 30 per day, so probably that's 30 per day, that's 201, so probably like 1,050, I don't know, maybe. That was off the top of my head. Not hard math, but you know me. I run into enough errors in programming, I don't need any math mistakes. From string. So yeah, see, we're converting it back into it, and it is dumb, I'll give you that. But like I said, the main point is to show you guys that how to convert to a, because I don't know if you ever looked at NumPy, right? You don't want to read it, I'll tell you that. You want to try to read it. Records.append. Really? That's what I did next? Oh no. What in God's name? Yeah, you don't want to hear that from the person that's giving the tutorial, do you? Okay. Oh yeah, and then you want to separate the yeah, okay, that makes sense. You want to separate the comma out. There's commas in there, you don't want commas. Dot format. string, and then we're gonna do string data, D type, what type you want it. I don't want that. I'm gonna want that as an int again, and then we're gonna run sep, and then we're gonna do bang bang, bang bang. All right, and then we're gonna return records. All right, that looks pretty good. Oh wait, no it doesn't. Okay, that looks pretty good. All right, so then we have successfully read in a CV, hopefully. And then we're gonna define the next function, which is, actually we won't. I'm gonna skip that. Don't worry, we definitely will come back to it since it's the main part of everything. But we don't, it wouldn't help you guys much right now if we went to go do that. All right, what we are going to do is we're going to write the CSV, and then we're going to read it in. So we need to write. Hip it to the hip hop, you don't stop. File name, and then book. Just because I really think I just did copy this. So then with open file name. And then we're going to pass in W as CSV file. Field names equals, and then obviously I just went over them, label with a capital, and then data. So like I just called them up there when I was reading them in. And then we're going to call writer equals csv.dict writer CSV file. Another thought just came in my head, but I'm like, Zach, figure this out before you talk. Oh, I did hit that end. Good job, Zach. Okay. Yep, and then writer.write header. Also doing it this way, step by step, we'll show you guys if there's any errors. So I equals 0, and then for ID in book. So I know that the first, this was in the tutorial when you go into it, that the first 12,499 are positive. So then for positive, we're gonna go like this, and then we're gonna do else. That's gonna be our label equals 0, 1. And then, oh geez, coming down with something. And then we're gonna write row. Write row, and then it's gonna be a dictionary label, and that label is gonna be, you guessed it, label, and then that data is gonna be, you didn't guess it, ID, or you did, who knows. Alright, so then we're gonna go to our main function, so then we're gonna do def main, and we don't need anything when we go to main, and main is just gonna be, I think I'm just gonna write the CSV first, so I'm gonna do write CSV. Well, actually, I'm gonna load it, so IDs equals np.load, and then I'm gonna do IDs matrix.py. I had to look over to it. You know, I'm actually gonna just do that just in case to let it know. Triple checking that I'm right there. I'm in it. we here? Oh no, it's not. It's not. It's NPY. It's a NumPy. Come on, Zach. You just went on a whole tangent. I don't remember. All right, CSV. All right, so then what I'm gonna want to write to, I'm gonna want to write to this, and I'm gonna want to write it to IDs.csv. Why not? Why it's called IDs? Who knows? All right, so then IDs. All right, and then that should read it, and I'm just gonna print out that I wrote to CSV. Wrote, bruh. Yeah, I said that. Yeah, I said that. What you want? All right, so then if man equals not man, and then we're gonna want to do all right, and then we're gonna come back here, and I'm gonna run not that, but sentiment data.py, and we'll just cross our fingers, hope that there's no, oh, it's writing to it. That's pretty cool. Yeah, it's gonna take a really long time. I'll tell you that right now. Not too long, but long enough for you to be like, dang, did I make a mistake? Probably not, but maybe. Take a little seat while this goes. I was gonna say something. Oh yeah, the other thing I was gonna say, I'll have to finish right now. Was the YouTube videos, the mean app 3, so part 7, broke up into, as I saw, at least 4 to 5 pieces. So who knows which one's the first one, which one's the last one? I know it usually goes the latest. The one that shows up first is usually the one that was recorded last. Oh, it wrote. Okay, so yeah, go to the one that shows up last in, like, if you go to my videos, and you go to the last one, and then you follow it chronologically. I'm gonna see if there's some way I can put them all into like a playlist in the right order. Should be possible, but we'll see. But yeah, I thought I'd throw that plug in randomly in the middle of this video. So who will actually see that? Nobody knows. But hopefully I'll have that playlist done, so nobody really needs to listen to this. But if you're wondering later on if I actually did end up doing it, the reason that this mean app 7 is that is because it broke up into a million pieces. I'm not going to say what did it, OBS, because I don't want it to stop on me, OBS. 100% will stop on me now, but just so you know, it just stopped. For some reason it kept stopping recording last time, and the one time it stopped recording, it just kept recording, and then this time it broke it up into like 3 pieces, so who knows. But, okay, you're going to open the CSV. It's going to take a while. Adam's going to be like, are you sure you want to open the CSV? You won't be able to do anything on Adam until we open the CSV. You're going to say, yes. Proceed. Because it's so large, it has to open. Oh, see, so it happened. So here we go. So we have this, and then we have, look at that. Look at this nonsense. It's so much, so much. So basically what this is if you follow the tutorial, here, I'll go to the tutorial. It's doing this. So it's basically the number you get is associated with a certain word. And that's word to vec. That's somewhere in here. I don't know. It's word to vec right here. So and it somehow correlates to the positivity of it. This is a neural network that was actually run. It's its own separate neural network. It was already run for this example, and then it was stored in this data format. So you don't have to do anything. You just, if you get a word, you use word to vec. Just like I said, when you use like the latest of your neural network, which we're going to be doing, and then you look up a word like "the." Maybe it's 14 because "the" is pretty. Well, maybe 14 is negative. I don't know. But yeah, so this is what it looks like. So then let's try to open up. I'm actually going to close this so we know that this is a positive one. Label, and then this is the data. So I'm going to close this because I don't want Adam freaking out for having so many large things open. There's our NumPy array. Okay, so clearly one is greater. One also takes up more space, CSV, but at least you know what you have. You can save to it very easily. And then we're going to read it in, and then we're going to transfer it. So we'll see. So you wrote it. Okay, great. So then we're going to comment all these out because we wrote it. Great. Now what do we want to do in this? We're going to want to do CSV to record. So TF record. We want to do CSV We haven't defined this yet, but it's going to be there. 2, TF record, because that's the thing that it's good. That's if you know how to write to a TF record, you can use any data. The only thing you're going to need to know is you're going to fool around with your neural network. That's all you have to do, which is the point of, in my opinion, deep learning. It's not to spend 2 months figuring out what the best data format is. Why I use done instead of wrote, who knows? But yeah, so it's to play around with your neural network and do cool things with it. So this is how you go from CSV to TF record. And now let's do it. So we already have our read CSV. Hopefully that works. And now we're going to go to make our TF record. So CSV to TF record. And we have our class already. So once we read it in, we are making a class. And that is awesomeness. So then we have a class, which makes it very easy. Let me say it one more time. Now we have a class. Ah, gosh. I talk too much. Maybe that's why I made YouTube videos. It's not to educate the youth as much as people think. It's to hear myself talk for 2 hours. Equals read CSV. No, if I wanted to hear myself talk, I would have been something other than a computer scientist. Because you sit at a desk and program in silence, which I enjoy. So this is how you write to a TF record. So tf.python.io, and then tf, we're creating a TF record. I want to make sure I get this right. Well, I'll know if I don't. And then here we go. Sentiments. This is what we want to save it as. TF record. Apparently there's an S at the end of that. T is sentiments. Yep. Let's go with that. And then we're going to do for rec in records. So yeah, we read the CSV and all the records. We're returning records. We're storing it as, again, records. And then we're about to write those records to a blah, blah, blah. It's going to a TF record through a Protobuf message. Protobuf messages are great. I actually didn't know about them for a long time. I learned them at my work, just for a whole different topic. But what ended up happening was Protobuf messages are bomb. A lot of people use them, and for great reason. So what it does is, maybe I talked about it before. Maybe I haven't. For those of you who don't know, oh gosh, that does not look right. Features. Why does features look so weird? Okay, then we're gonna do a feature again. I don't know, that word looks really weird today. I don't know if you guys ever had that happen, but it's a real thing. All right, so then, okay, so Protobuf messages. Jeez Louise, get on track. All right, so Protobuf messages. They are basically classes that are stored that you can send to and from, and then whatever gets it, we'll put it into. It's going to be a uniform type. So say I have an int. Ints can be different on so many different computers, different computers, processors, same thing. Different languages, depending on what OS you're running. So Protobuf messages make it uniform. You have an integer is going to take up a certain amount of space. A string is going to take up a certain amount of space. A byte is going to take up a certain amount of space, no matter what operating system thing you're on. So that makes it really great. And I learned that the first time I learned about them, but then I was like, okay, cool, whatever. And then they show up everywhere. I was like, oh, this is awesome. I already know about them. So, feature. And then I'm going to do int. Tell what type do you want? Int 64. But it's going to be a list of ints of 64. And then equals tf.train int 64 list. And you guess who makes Protobuf? By the by, whoever says that these days, my nana does, so don't hate. Then we're going to get the label. Google makes Protobuf Messages. So who makes Tensorflow? Google. It makes sense that they go together, I guess, that they were trying to use it, but it is just a great thing. So whether they would have used it or not if they made it, I don't know. Couldn't tell you, but they do, and it's great. You just gotta love it. Who else makes Google Assistant? It would be Google. So they are on top of the game. As I write, let me think of other fun facts, little tidbits for you guys. Yeah, I got nothing as I type. So basically what we're doing here, I'd like to finish it before I got started, because you know me, I'm never gonna finish. rec.getData as type. So it's a NumPy list of ints. Oh, I have another comma apparently. Why? Okay, well, comma. Jupe. Jupe. Oh, wait. Comma. Good. And then outside of this, we're going to do serialized. Right outside of the for loop. No, oh, GeForce driver. I thought you were going to be. Why would I do that? That doesn't make much sense, Zach. Alright, well, it says to do it in here, at least, I don't know. Okay, so I'll go over it after. So basically, we're still making it into a example.serial. Serialize to string writer. Oh yes, it does make sense. Why it's in the for loop? Because example is inside serialized. Alright, so then we do that. Alright, so that should be good. Then we should be able to save that. So what's going on is we're creating a Protobuf message of that's an example, and then it has a subset of features, and then the feature of the feature is label and sentiment, and this one is going to be they're both int64 list, and then they're both tf.int64 list. So they're list of ints, and the int type and the int value is going to be of 64 base. Value is going to be equal to record.getLabel and record.getData, and then as type 64. And then you do all these things, and you get a nice Protobuf message. Oh yeah. And then we serialize it, example.serialize, so that's an example, and that's why it's in the loop. And then we write the serialize to the writer. And then I don't close the writer. Probably should try to close that. So I never did this before, so I should have actually, just not in this example. Somewhere I probably have thought to close that. I don't know if that actually works, but you know, when it leaves the function Python garbage collector comes through, it's like num. You don't. All right, so let's run this and see what happens. My guess is there's going to be errors in this. Yeah, recording is not recording. I thought where's recording? Why the heck would I call it recording? Control F, recording. One result. Well, yeah, I want to find it. I get Control F. Alright, why would I call it recording? You know, I'm going to blame Adam for that one. Yep. That's what's going to happen. If that was it, man, I'm going to have other errors, and I just don't want that. Alright, so from at string from it would have been worse if I didn't have that T, because it would have looked like I just from a string, which isn't just a funny thing. It's just a alright, from form string. You dummy Zachary. It's my full name, by the way. First name Zach. Full name Zachary. Oh geez, well I'm printing something out. I don't want to do that, but it's working. Don't you worry, it's working. Where am I printing? No. It's probably in here. Yeah, there it is. Yeah, there it is, because I want to make sure, yeah. That makes sense. Just give it a little bit like the other one. So we're at 0, 1, so that's a negative. So we went through all the positives already, so there's about a half of each, so each fill up half. Maybe that's a more appropriate way to say it. Yeah, so we're creating a TF record now of everything that we saved in the CSV. So the appropriate thing to do would have been to take the, so here I'll open up my CSV again, and Adam's going to be like, you sure? And would I have clicked on it, Adam? Probably. I click on a lot of things I don't tend to open, but it's always nice to get mad at Adam. So yeah, the appropriate thing would be probably to save this as negative, and then save this as I had a terrible day. Adam kept asking me questions. And then when you open this up, say that, okay, if equals negative, set it equal to this, and then set it equal to this. No, scratch that. Use the word to vec to make this, and then come back into sentiment data and use those two things into, so read them as from the CSV, and then convert them to their appropriate arrays, and then use that here. Save that into the class instead of taking in the NumPy arrays that we have and sending those, and then parsing them, and then parsing them by this and sending them to the array. It makes a lot more sense if you do it the other way, the appropriate way, clearly. The way that makes more sense. But why I'm doing it this way is because the tutorial gave me the IDs matrix.np that I already had, that had all of these things. So I was forced to use an NumPy array. It doesn't give sentences, it gives the word to vec values. So that's why I was forced to use it. But this is just to show that of how to convert something from a CSV to a TF record. So yes, it's a little redundant and silly, but the main point is there, and it's a really good point because it took me a while to figure this out. So yeah, I think it's just all around, everybody should know how to do this. So then now we have our TF record. It's saved over here as sentiment TF record. Great, goodness, love it. So now we're gonna have to read that record. So then we're gonna do a TF record read. That's what we're going to create. Some of these we're going to use, and some of them we're just going to demonstrate. So def TF record. So how to read a TF record is pretty easy. Read, we just wrote one, so that's greatness. Like I said, then you could also use the MongoDB, the REST API, to also write to it. So it doesn't have to be CSV. As long as you know how to get the information, you can convert it to the integer list and then save it as TF record. So that's all you need to do. There's also, as I should state, that there's so this is a valid thing. There's also byte list, I think, and that's for like pictures or strings or whatnot. You save them as bytes instead of their other formats. So it's integers and bytes are easy to work with. So yeah, I should say that. So if you want to use pictures, there TensorFlow and pictures, it's been figured out for a long time now. Anything you really want to do with pictures, they have it solved. So you just have to change a little bit of code. But for some reason, nobody wants to work with strings, and I don't know. I like to know if I'm a happy guy today or not. All right, so then we're gonna take a thing of people, probably because I was thinking about the context, which would not make sense at all to include context into your thing. Just maybe to see would the next person I add, would their name be start with a G based on previous results? But it'd just be silly. That's just random. Or is it? Dun dun dun. Alright, so we read all this in as for, and then we do example equals tf.train example dot example. No, they didn't even gotten to the but this was this. I think what we just covered, what we are technically still covering, is just like reading in the stuff. Parse from string. It's very useful. If I should say that one more time throughout this, clearly it's useful. I'm going over it. Stop talking, Zach. All right, cool. All right, number equals example.feature dot feature. Did I save it? No, I saved it as label and label and sentiment. So this is wrong. I know what I was doing. So that makes me think that we actually don't even need this function. But it's good to know, so I'm going to keep it. So label, and we'll actually just change this to label. In 64 list. Because technically when you go to your neural network, you don't want to read one value, you want to read many values. So that's why this is the way it is. So then we're going to put this as data equals example.features. Well, hopefully there's no error because I am just copying and pasting. Alright, so then we're going to do people.append, and that's also why it's called people. People.append record, and then I'm going to do label data. Good, and then we're going to return people. All right, then let's read it in. Let's see if we can do that. How about? Oh, geez, we got a lot to go. How much time do we have? Oh, that should be plenty. Oh, baby. Maybe, actually. Maybe not. Maybe I should get a move on. Yeah, so... where is that main part of it? Alright, so I'm gonna go back to this main function so I can show you guys. So we're gonna read it. Nope, CSV2 record, we don't want to do that. We want to read it. So we're gonna do CSV2 record, CSV2, nope, no. Sense equals TF record. Read sentiment .tf records, and then we're gonna do for, oh gosh, no, we don't want to do that. So we're gonna do sense 0 label sense 0 data, and we're just going to do print that should work. Alright, so that should just print the first one. Otherwise, I was going to try to print all of them. Cross your fingers. Oh, no capital train. What was that? Who did that? No, not right, CSV. Train, there you are. I know it didn't, Man, you should make a neural network that goes through and fixes stupid mistakes. Learns, oh, that's a good idea. Learns me as a programmer. That's what it should do. I don't think I ever want to program that IDE. That would take forever. So it's reading them all in. Just it takes a while, but it's because there's so many. That's what makes, there's more than 100,000, I think, and that's why training is going to take a long time. Reading it takes a long time. Oh, of course. From Matt. Now I gotta do that all again. Just because I can't spell. Actually, I wouldn't need it to be a neural network IDE. I would just need it to be a... Atom doesn't have an extension, at least that I know of, that knows of TensorFlow. So when I import it, it doesn't have autofill. I just need one that has good autofill. Then I wouldn't make so much stupid mistakes. Record is not subscribable. Alright, well. I'm returning so many. Oh, that's why. You're right, it is not subscribable. It is .get labelable. Alright, I should really pick up the pace here, because we still have to go through. And actually, that last part won't take, oh my goodness. I think it doesn't take a while. We shall see. This next part, though, and you'll see. This next part is going to be all neural network. And I can probably show you of that. Alright, so yeah, we do the TF record, and then the next one is going to be, yeah, def. No, I don't want to do single sample. Okay. Okay, interesting. It gave me get label both times. So, oh, that's because I put the, and I'm not gonna run that. You can run that if you really want, and check out if it works, but it works. Probably. Alright, maybe I'll run that later if I have time, but it really isn't that important. That's just how you read it to make sure that it's actually working. So there we saw that we had a 1, 0, and that means that the first one should be positive. We're outputting the positives first, so that's good. And I'm assuming the data would be right along with it, so probably not the best thing to assume, but all right. So then now we're gonna read and decode single sample, which basically just means that we're gonna get it all ready, primed and ready to go. Single example, which is kind of what we did, but we want it all ready to go into our neural network. So the file name is going to stay the same. Bada bing, bada boom. And then we're going to go right into a function. And then we're going to do file name Q. And if we had a Q, it'd be nice, but we only have one file, so this really is going to be file 1Q. Dot train. Dot string, input producer, input producer, because we're going to file name, and then we're going to do num epochs none epochs. Boom. And then that's nice and ready. So the file name queue. So then we're going to do reader. Okay. Dot tf record reader. Boom. So we have tf record reader. And then we're going to do, we're not going to do the first one. We don't really care about the true or false. Serialize. Just example equals reader.read file name queue. Boom. Now it's nice and ready to go. And then we're going to do the features. Equal tf.parse single example serialized example. I want you down as well, just because it looks better. And I really would like you to be 1, 2, in. 1, 2, in. 3, 4. Okay, because it's Python. Features equals label tf dot fixed len feature fixed len feature 2, and then they're going to be of tf.n64. Bing, bing, bing. Alright, and then we're going to do sentiments, and then we're going to give it tf.fixed, fizzed length. No, it's not a soda. Fixed len feature, but this is going to be of, so we're going to, everything is kind of saved in 250, so that's what we're going to use. That's the max length that we kind of picked up. If you go through the tutorial, you'll see that as well. Boom, boom. So then the features closed. So then we have label equals feature label, and then we have number, data equals features data, and then we're going to return label data. All right, beautiful. And now we're about to get ready for our neural network, so get excited. I know you are. All right, so then we go into our main function. And we did all of that. Boom, boom, boom. All right, so we are going to do, we first have to declare a batch size, because we're going to be reading in those singles as batches. So we're going to declare our batch size as 24. We're going to declare LSTM, which is basically, we're going to be using what's called, okay, maybe after I type these variables, classes. We know num classes is going to be 2 because positive or negative. Iterations is going to be 100,000, 100, 1, 2, 3. And then, like I just said, it has 100,000 in there. So the max sequence length is going to be 250, like I said. And then the number of dimensions is going to be equal to 300. And then we need the word vec to understand kind of what these things are. np.load. So you still need an np array, but it's not the one that you're kind of acting on, so that's okay. And you know the data, you know everything, so though we're using one np, it's okay. So tf.reset default graph. And we are going to be able to look at the graph, so that's nice. tf.reset the default graphs. Alright, so then we're going to create a labels. Labels is going to be equal to tf.placeholder, tf.flow 32, and then we're going to have a batch size. How many do we want to get? Batch size, and then num classes. Yep, it's 2, so that makes sense because it's going to be a 0, 1 or 1, 0. And then we're going to have input data, and then we're going to have equals tf dot placeholder, tf dot in32, batch size, max sequence length. Good stuff, because yeah, it's going to be the batch size, and then we said that they're all 250, and if it's not 250, it'll just add zeros, and the zeros, they get taken care of, so don't worry. They neither add nor take away from the positive or negativeness of it. So then we want our data, so data that variable, so we're going to fill like zeros, just like we filled our weight with the other one, zeros. Batch size is usually, oh dang it, there you go. Batch size, tf zeros, batch size, max sequence length, and dimensions. And then we're gonna want to make it of dtype equals tf.float 32, and then we want to set data equal to tf.nn. It's a neural network embedding lookup. So we kind of want to figure out what's going on with the word vector. Right? Did I say it? Word vector. Yeah, we'll make that nice. So word vectors. Input data. There it is. Alright, so then we need an LSTM cell. So an LSTM cell, what we're using is a neural network. And neural networks, if you read the O'Reilly tutorial that we were going over, it's basically they might go over it better than I will. It's how much memory. So you have a recurrent neural network. A recurrent neural network is what we're using here. So basically, a regular neural network without a recurrent neural network, like a convolutional neural network, is one that it takes in pictures, and based on that one picture, it looks at all the pixels and it says if there's something there, like a orange or a pear, and that's it. What a recurrent neural network will do is what we really want. So it takes one word, so the, and it's like, okay, that's the, and like a regular neural network would just be like the. Word or not word would be like a neural network for that, and then it would just be like I've seen something like this before. It'd be terrible neural network. That should just be hard-coded, in my opinion. What a recurrent neural network does is it remembers the words before it. So, like, I loved great pizza. If it just looked at I, it'd be like, not sure about this. loved. Okay, that's a positive word. So that word is positive. This word is positive. Great. But I wouldn't connect them. What we want to do is, I loved. Oh, it's getting more positive. Great. Okay, this sentence is getting very positive. Pizza. Kind of neutral, in my opinion. It's also a very positive word. But just so it builds on the words before it. So they might do a better job of it. And so the LSTM is to help remember what's going on there. And then we're going to want to do LSTM units. Units. I don't know if I defined that. LSTM units, didn't I? Up here? Yep. Unit. Unit. Alright. So yeah, we have LSTM units. And then we need to fix the LSTM cells again. Equals TF dot contrib dot RNN dot jump out wrapper cell equals LSTM cell output keep probability 0.75. Output keep probability equals 0.75. Alright, good stuff. And then we have value underscore equals tf.nn dot dynamic, like I said, we're using RNN, LSTM cell. So yeah, if you want to build on it, like say you have a video and you want to tell, what would you want to tell with the video that would use an RNN? If it's sunny out, maybe that would be a good recurrent neural network. Yeah, one picture might do the trick, but maybe there was shade in it, so you want to have like a continuation. So that could be it. That's a good one. I don't know. So then we're gonna have our weights just like before. TF dot truncated normal. STM units. Classes. Boom. Bias again. We're gonna have our bias equals TF dot variable. TF dot constant 0.1. Shape num equals num classes. Beautiful. And then we have a value that's going to be equal to TF dot transpose value 1 0 2 last equals TF dot gather value 1 nope int value dot get shape dot get shape 0 minus 1. Alright, prediction, it's all coming together. tf.mapMore last weight plus bias and then correct pred equals tf dot equal tf dot argmax prediction 1 tf dot argmax label and then 1. Alright, pretty good. We're getting there. And now we need to do the accuracy, the loss, and then we're gonna start dun dun dun. Alright, so then we're gonna set it up for running through it all. Loss equals TF dot reduce. No, we need to do accuracy first. Accuracy actually equals TF dot accuracy equals TF dot reduce mean. So again, just like on the neural network before, TF dot get cast correct pred TF dot float 32. Loss equals TF dot reduce mean TF dot NN dot Softmax cross entropy with logits. Logits equals prediction. Prediction. Labels equals labels. Then we have optimizer. That's going to be equal to tf.train dot add optimizer. Optimizer dot minimize loss. Alright, so we're optimizing it. So now we're going to want to do df.summary dot scalar. So we're also going to be working with TensorBoard, which is really nice. It's going to show us kind of what tf.summary it's going to kind of give us a summary like I just typed. So merged equals tf.summary dot merge all. Merge all. And then log there equals plus date times datetime dot datetime dot now dot string f time, and then it's gonna be our nice little similar to what we did with year. D H S. Alright, that looks good. And then we're going to give ourselves a session so we can get started. So that's all for TensorBoard, which we'll see. TensorBoard gives a nice visualization of kind of the accuracy and loss, which we just interactive session. Writer equals tf dot summary dot file writer logger session dot graph. All right. session.run. So this is to visualize it all. So tf.global variable initializer. Boom. And now this saver is going to be for saving it, so we can use it again. Dot train dot saver. Beautiful. All right, so then label and sentiment is going to be equal to read and decode single example. Read and decode single example sentiments.record. TF records. Alright, so then that gives us our label and our sentiment. Alright, so then we got sentiment batch labels. Interesting. I don't know why they're like that. Thought they'd be switched, but okay. TF dot train shuffle batch. So this part is very different than the tutorial. Label batch size, then what's on the O'Reilly, because this is using our own reader and our own writer. Capacity equals 2, 1, 2, 3. Min after DQ equals 1000. Beautiful. Session equals tf dot session dot run tf dot global variable initializer tf dot train start queue scared to go. Start queue. Runners. Session equals so for I in range. For I in range. Alright, we're gonna do next label. Don't worry, we're almost there. Next labels. Next sentiments equals search.run. Labels batch. Sentiments batch. Alright. We'll do session, well, until we get errors when we run all this. Optimizer. Input data. Next sentiments. Labels. Next labels. That should be that, actually. Right. Jeez, I'm losing my mind. Yep. Alright, good to almost go. And this will take a really long time, but a nice thing about it is we get to look at it while it goes. So I really hope we get to. All right, I have 8 minutes. So the testing part might go a little quick, but it actually is quick in general. So summary session.run merged. So this is basically to say input data is going to be next sentiments. This is going to be for output to the tensor board again, labels, next labels, boom, boom, writer dot add summary. Summary I, boom, and then we're basically just gonna say if it's divisible by the, this is modules, by the way. I'm pretty sure we went over this. If it's divisible by 10,000, we're gonna see this 10 times. We're gonna, which equals 0. Yep, I'll put that there. And it doesn't equal, and I doesn't equal 0, because we don't want it to do it on the first one, just when it equals 10,000 at some point. We're going to want to save this. We're going to want to use by using saver.save. Saver.save. Slash, and then we're going to models slash pre-trained LSTM dot CKPT. Yep, and then global step equals I print saved latest. And then when we come out of this for loop, we want a writer because we called that writer up here, right? Where is our writer? Yep, writer equals, yep. Okay. All right, and now this should work. We're gonna have errors, I know it, but we might as well try. I'm not gonna, oh yeah, that makes sense. That one's really easy. So I'm not gonna train it because that'll take 2 hours, but I do have a pre-trained one. I didn't save it. I do have a pre-trained one, so once we get through all the errors, I'll run through that pre-trained one. LSTM units is not defined. You don't know how to fix that. You go up here, LSTM. Beautiful. I'm gonna sit down for this. Oh, sweet, it worked, kinda. So that's good. Man, Touchable has no attribute TF record reader. That is in, I know where that is. That's in here. I assure you that's not wrong. It's just wrong at the moment. So it's going to be tf.record. Does it just R is capitalized? So, all right. I'll go 50-50 on that console CMDer. Half my fault, half your fault. Oh, sweet. In record reader feature data equals features data. Keyword data. Data is there. Feature label. Oh, you right. All right. Now let's see this in action. So yeah, I mean, I won't test this, but I do have, like I said, pre-saved. Oh no. Whoa. Unknown feature data is not. Data type button could not be found. Name unknown feature sentiments is required, but one cannot be found. I tried to, I'm trying to stop this. All right. So what happened? Sentiments. Okay. Then we'll go back up to how I saved it. Or did I call it data? Sentiment. I call it sentiment. Maybe. Maybe. And then when you go to here, you know, maybe it would have benefited me a little bit if I thought yeah, it's okay, so it's not going into there, it's just reading. Okay, so let's see if we could get back to there quick because we're running out of time. Safety and security loves to kick me out. CPP live part 8. That should be good. So it gets into the TensorFlow part, and then let's see. So far, so good. So if we do TensorBoard start, nothing yet. We won't see anything, which is appropriate. If we run TensorBoard logdir equals d/documents/cpp live problem solving part 8. That should work. And maybe I don't need the TensorBoard part, but maybe I do. Localhost is actually going to be 60006. And we can kind of see it in action. No boards are currently active. Interesting. Well, okay. So this hasn't stopped yet, so that makes me think that it's lying. So then I could do this. And then I'll take this out. And then I'll run it. And then we'll refresh. You gotta be kidding. Because there that is. So that'd be nice. So there, it's there, it's just not showing up, and I cannot figure out why. I don't know. I mean, what if I copy this? I mean, that should just be localhost, but you know, we'll reload this one more time. No, it should. Shouldn't make any sense. It should. It's gonna say the same thing. Yeah, I know, but I know. So let's Control C it, because this is nice to see. So I kind of want to. TensorBoard. Because look, we got a couple. They there. We know it. Localhost. Oh no, not 3000. D. It's gonna say the same thing. I know. it should just show up whenever, if you have something, it's going to show up no matter what, so. I'm confused. Because I know it's saving, so maybe it's just in TensorBoard. So let's Google running TensorBoard. Let's see. Down the bottom. Dash dash, yeah. Equals path to log directory. Oh. Alright. Control C. And then I'll paste this. Yeah, that's the same. It don't know. Oh, maybe I have to be in the. I don't know. Hey, there she is. All right. All right, this is terrible. This is god awful. All right, something is wrong. Oh no, accuracy's over here. Okay. Oh, actually, it's really good. So the accuracy was actually at 1 in the beginning. The loss was close to 0 in the beginning, so then it's coming up. So if we watch this go for a little bit, these will get smaller, these peaks. But yeah, this actually looks pretty good. Usually I have the loss on the other side, so if I could rearrange these, I don't know. So I guess I just had to be in my D drive. I don't know. I guess that makes sense. All right, so it's working. It looks like it's working at least. I'll probably run this at some other time, and then I'll get back to you guys if it wasn't working. But it really looks like it's working. These will start to. They're actually better than I thought I'm expecting. So maybe that's concerning, but they might be leveling off a little faster than I thought they would. But yeah, so I'm actually going to stop this. Control C. Yeah, and then I'm going to stop this as well. Control C. So then I'm going to go over to. I'm just going to go over to the testing one. So then you guys can just. I'll just kind of scroll through and you guys can look through it. And I'll just kind of go over it because I'm kind of running out of time. But basically, what you have to do, this right here, this line, it's only for. It's for that error message. It takes that out. So if I used this with my Node.js, my response would be sent with my response, and I don't want that. So I just say, never mind. So then what I do is, basically, if it's a correct sentiment, if it's positive sentiment, then the first one's going to be 1, the second one's going to be 0. So 1 is greater than 0, so then it's positive, and then otherwise it's negative. To clean the sentence that comes in, I don't want any. I want it to be lowercase, and I don't want any characters. So that's how that goes. And then get sentence. Again, we're just cleaning it. This is within the tutorial. So then basically I put this in. I hated the show. This is clearly a negative sentiment. Num dimensions, and I have all of this. Basically, reload the word list. We load. A lot of this is very similar. These are all very similar. It's very copy and paste. And then we get down to here, basically copy and paste everything, but you don't want the loop. But you want, instead of saver.save, it's going to be saver.restore, and it's going to be the checkpoint, the latest checkpoint in models. So that's going to be in here. We actually probably didn't save anything in models yet because that only happens at 10,000. Yeah, so then we're going to strip the special characters. And then we're using argument 3, and we're getting the sentence. Yeah, so then we're returning the predicted sentence. So then where do I have this saved? CS record. So then if I go here, cd deep csv to record, and then I'm going to do Python. What do I have this saved as? Test training. Python testing train.py, and it should end up saying, because I copy and pasted them. So just oh my goodness. Oh yeah, Adam. Me and Adam, one of these days is gonna get in real tussle. All right, but we're gonna go in here. I'm gonna go here. Live part 8. And I'm gonna copy this word list. I think is the one that's copied. Yeah, word vec there. Force close. All right, bye, Adam. I knew I was mocking it. So documents, deep learning, CS record, paste, and it might take a second. Nope. All right, cool. Close. Test training. Negative sentiment. And I said it was a negative sentiment. So now if I change it, which I will do, I'll go up here. Basically, I can just change all the other. I loved the show. It was a great performance. Maybe could use family. I would love to watch it again. It was so amazing. So let's see. We do this, we run this Python. Bum, bum, bum. As long as I spell amazing right, it'll be positive sentiment. So there we go. So I'll make sure that that worked for you guys. The reason I'm just a little skeptical is because usually it's around 60% when I first started. But that's all depends on how good of a guess, because what happens with a neural network when it first starts off, it just makes a random guess, and then it works its way from there. So if it made a really good guess off of the first couple of predictions, then yeah, it could be high. And then it looked like it was learning, so you're going to get that jaggedness in the beginning, and then it's going to look like that probably until about 50,000, and then it'll start to really level off towards 1. That's what you should see on your tensor board. But yeah, I'll run that again tonight, and if there's any problems, look for my GitHub page for any corrections that you might need to put in. But anyways, yeah, that's it, guys, and I'll talk to you guys in a couple of weeks now. Hopefully we'll go over how to look into, oh gosh, that's deja vu. Not deja vu, what is it called? I don't know, some mirror effect. Yeah, anyway. Yeah, we'll go over kind of how to get the data into our C++ and maybe Python applications, go over AI, which is, again, really easy to include with our REST API setup, and along with, what was the other one? There was another one. Oh, images and stuff. That's very easy as well. All right, guys. Well, hopefully this was a good tutorial. I'm sorry I didn't get to go over all of this really in depth, but it's really short, and you can kind of see what's going on. So, yeah, we've passed the sentence in, and that's what we're doing. In the word list, and then basically we're just kind of converting the sentence that we passed in, we're cleaning it up, we're splitting it, and then we're kind of getting it into that word list, and then we're returning it. And then when we get that down here, input matrix, we run the neural network, the saved neural network with that input matrix, basically. Yeah, so hopefully that is good with you guys. And yeah, I'll go over that again, and again, look for my GitHub page. It'll be in the README under part 8 if anything goes wrong. All right, guys. Good luck to you. Talk to you guys in the next one.